today class I am going to cover only log based protocol. Okay, so other things we will see in the next class. Okay, so log based protocol. So when we will be using a log based protocol, now if there is a concurrent execution of a transaction, in that case there is a need for using a log based protocol. Okay, so if more than one transactions are trying to access the same data item, then your database will be in an inconsistent state. In order to make the database in a consistent way, before any transaction, if it wants to use any data item, first you should get the log for that. You should get the log for that, then only it can able to access that particular data item. Okay. Okay, so we are going to see transaction. Okay, T1 is your transaction. There is a one data item that is Q. Okay, so T2 is another transaction. T2 is another transaction. T1 is a one transaction. T2 is another transaction. Q is a data item. Q is your data. Okay. So for example, both T1 and T2 are executing concurrently. Both the transaction T1 and T2 are executing concurrently. So if both are trying to access the same data item Q, then your database will be in an inconsistent state. For example, the initial value of this data item is 1000. Okay, the initial value is 1000. For example, it is doing the read operation 1000. Okay, so here the Q value is 1000. So T2 is trying to update this value and it is going to make this value as a 2000. T2 is changing the value as a 2000, updating the value as a 2000. But the value for the same data item Q, the value which is available with the T1 is 1000. The value which is available to T2 is a 2000. It should not happen like that. If it is happening like that, then it only means that database is in an inconsistent state. Data is not accurate in the database. So whenever you are trying to execute concurrent transaction, your database should be in a consistent state. So for that sake only we are using the log based protocol. So for whenever a T1 needs to use a data item Q, then first it has to get the log. Okay, that time if T2 is trying to get the data item Q, it could not able to get. Why? Means the log is holded by T1. Until unless the log which is holded by T1 is released, then only T2 can able to use it. Okay. So in that way only we are going to use a log based protocol. Okay. Is it understandable? Is it understandable? Yes or no?
Say again.
Okay. So in the case of log-based protocol, if any transaction wants to use the data item, any data item, it has to get the log for that particular data item. For example, and if there are two persons in your class, but there is only one object, both the person cannot able to access that particular object. Okay. So what you will do, if I am the person, you consider myself as a log manager, you consider myself as a log based protocol. So what one person will come and we can take one example from your class for that, the two person. Okay, I'll take Vaishnavi and Yuvarani. So Vaishnavi and Yuvarani are the two persons, okay, who is in the class and there is only one object is there. So I am the person who is responsible for allocating that particular object to any persons, okay. So if Yuvarani wants to get that particular object, for example, chalk piece you take. So if she want to get the chalk piece from me, first she has to ask me. So if I am saying yes, you can take now, then you can take. So I'll be giving the chalk piece, that is that particular data item, to Yuvarani. That time, if Vaishnavi is trying to trying to access chalk piece, she could not able to get. She could not able to get. Why means that particular data item is holded by Yuvarani only. So I only given permission to Yuvarani to hold that particular data item. It means Yuvarani is having the lock for that particular data item and she is using that particular data item. So read operation and write operation she is performing. Okay. And what Vaishnavi will do now, she is requesting, but that particular data item is not available. Why means it is holded by Yuvarani. So she has to wait. Vaishnavi have to wait. So what Yuvarani will do, she will use that particular data item. Once she use that particular data item, she will release the lock. She will release that particular object. So that object will come to me. Now I will allocate that object to Vaishnavi. Okay. So and now Vaishnavi will use that particular data item. That time if some other person is trying to access that particular data item, it is not possible. Okay. But if it is a read operation, then every one of them can able to perform the read operation at the same time. For example, Yuvarani and Vaishnavi, both of them want to perform the read operation. They can able to do the read operation at the same time. But one person is want to perform read operation, another person wants to perform write operation. Now, it is not possible simultaneously. It is not possible. Okay. So lock is a mechanism that is used to control the concurrent access to your data item. So concurrent access to your data item, you are preventing concurrent access to your data item. So two person cannot access the same data item. So you are allowing only one person to access that particular data item by using the lock. Okay. And there are two type of locks which is available on any data item. First one is exclusive lock, other one is a shared lock. So two modes of operation that they are saying: exclusive mode, shared mode. Exclusive mode is denoted by X, shared mode is denoted by S. Okay. Exclusive mode, when you will be getting the X lock means whenever you are trying to perform any write operation, whenever you are trying to perform any write operation, that time you have to get the exclusive lock. That exclusive lock, what statement you will be using now? Lock X. Lock X. This you will be using. Okay. Lock X you will be using. So other one is a shared lock. If you want to perform the read operation on a particular data item, then you have to request for the shared lock. You have to request for the shared lock. So that instruction which we will be using is a lock S. Lock S. Okay. So two locks are there for any data item. One is an lock X, other one is an lock S. If you want to perform write operation, then you have to get lock X. That is exclusive mode. If you want to perform read operation, then you can get lock S. So if two persons are trying to get lock S, that two person can able to get lock S. It is they are going to read the data. They are not going to update the data. If Vaishnavi and Yuvarani wants to read the same data item, they can able to read at the same time. But Vaishnavi want to perform read operation, Yuvarani want to perform write operation at the same time. Now it is not possible. That kind of lock won't be provided at the same time. But the lock S can be provided to both the person at the same time on a particular data item. But different types of lock to different person of on the same data item, it is not possible. It won't give. So there will be a lock manager. That lock manager is responsible for granting the lock to the transaction. Granting the lock to the transaction. Okay. And here you see lock compatibility matrix. So as I told, you consider two persons. Okay. So if both the persons trying to get the S lock on a particular data item, then it is possible. True is there. S lock by first person and S lock by other second person. It is possible. Two person can able to get the S lock on the same data item. It is possible. But in all other cases, it is not possible. One person is requesting X lock and other person is requesting S lock. Then it is false. It is not possible. You cannot sanction both the lock at the same time. And similarly, X lock and S lock and X and X. In all other cases, it is false only. That means there is a one data item is there. Both the person wants to perform read operation, he can able to perform read operation at the same time, parallelly, concurrently. But on the same data item, if one person is performing read operation, another person is want to perform write operation, then it is not possible. Then it is not possible. Okay. Is there any doubt with this log compatibility matrix?
No, ma'am. No, ma'am.
Okay. Others?
No, ma'am.
And here is a one example. So previously, in the case of previous classes and all, we have seen the schedule. And in the schedule, we had only statement read, write, read, write, read, write. Like that only we had the statements. We don't use the log X and all. Okay. But here, so we are adding, since we are going to use a log based protocol, before accessing any data item, first you have to get the log for that particular item. So that statement is also added here. Here you see T2 is a transaction name. Okay. And log S on A. So S log S is used to perform read operation. Log S is for performing read operation. So if the transaction T2 want to perform the read operation on the account A, then first it has to get the log S on the data item A. Is there any doubt in the first statement? Is there any doubt in the first statement?
No, ma'am.
So once it gets a log, then only it can perform the read operation. Once it performs the read operation, then it can unlock that particular data item. Unlock means it can release that lock. It can release that lock so that that lock can be allocated to any other transaction. Okay. So first, any transaction, if it wants to access any data item, it has to get the lock for that particular data item. So here T2 is a transaction that gets the log S on the data item A. And then log S means it is a read operation. For read operation only we will be getting log S. So it is performing read of A and then it is unlocking it. Okay. And similarly T2 also wants to read B value. B value. So it has to get the log for the data item B. Log S on B. Read B, unlock B, display A plus B. Okay. Is there any doubt with this? Is there any doubt?
No, ma'am.
Okay. So what do you mean by locking protocol? Now, locking protocol is a set of rules that should be followed by all the transaction while requesting and releasing the locks. Locking protocol is a set of rule that should be followed by all the transaction when it is requesting and releasing the locks. Locking protocol restricts the set of possible schedules. Okay. So locking protocol definition is it is a set of rule that should be followed by all the transaction while it is requesting and releasing for the lock. And here you see, whenever you are trying to use a lock-based protocol, there is some pitfalls. Pitfall means disadvantage. You can say that as a drawback or the disadvantages. Okay, pitfall of a log-based protocol. So whenever you are trying to use a log-based protocol, there is a one problem that occurs, that is deadlock. That is deadlock. Okay, so you consider this example schedule which I have shown here. So here you see two transactions are there, T3 and T4. T3 and T4, two transactions are there. What T3 is doing? T3 is getting log X on B, log X on B. Okay, and then it is performing the read operation on B. B value is modified. B is equal to B minus 15 and write B. Okay, and it is not released that lock. It is a holded. That lock is holded by T3 only. And you see T4. What T4 is doing? T4 is accessing the data item A and it is getting the lock S on A. Okay, and it is doing the read operation on A and it is also asking for lock S on B. Whether this will be granted? Whether this will be granted?
No, ma'am. No, ma'am.
Why?
It is not unlocked. Yes. It is not unlocked.
Yes, data item B, that lock is holded by the transaction T3. T3 is holding the lock for the data item B already. But here in T4, it is trying to get the S lock on the data item B. It is not possible. Why? It is not released by T3. T3 is only holding the lock for the data item B and it is not yet released. Okay, and so T4 has to wait. T4 has to wait. Who is coming? This Pallavi. Pallavi, at what time you are getting into the class? After half an hour? So T4 is waiting. You see T3? T3 what it is doing? Lock X on A. Whether it will get the lock? Lock X on A?
No, ma'am.
Why?
It is not released the previous lock.
Yes, lock the data item A. That lock is already holded by transaction T4. T4 is holding lock S on A. Now lock X on A is requested by T3. It is not possible to grant that particular lock. So this is also in a waiting state. Transaction T3 is in a waiting state. T4 is also in a waiting state. T3 is waiting for the lock on the data item A. T4 is waiting for the lock on the data item B. Now, both the transactions are in a waiting state only. Either one of the transaction also cannot able to complete its operation. This kind of situation is known as a deadlock. This kind of situation is known as a deadlock. Now, how can you overcome from this deadlock in this scenario? What is the solution for this?
We have to release that lock holded by T3.
Yes, either T3 or T4 must roll back. Either one of the transaction must roll back. Either T3 have to roll back or T4 have to roll back. Then only the respective locks will be released, so other transaction can able to complete its operation. Okay, any one of the transaction has to be rolled back in order to overcome from the deadlock. Okay, is there any doubt here?
No, ma'am.
Boys are not getting any response from the boys. Is it understandable?
Understandable, ma'am.
Okay. So as I told, in the case of log-based protocol, the limitation is there is a chance of occurrence of a deadlock. So in some situation, if a deadlock is there, then there is a chance. The solution I told that here, if a deadlock occurs, in this situation, deadlock occurs. The solution I told that either you have to roll back T3 or you have to roll back T4. If I am doing like that, then there is a chance of a starvation. There is a chance of a starvation. Why there is a chance of a starvation? Na? For example, T4 is rollbacked. T4 is rollbacked. So again and again, if T4 is rollbacked frequently, then T4 cannot able to complete its task. So it has to wait for a longer period of time. It cannot able to complete. If T4 itself roll back for several times, if T4 itself roll back for several times, then it has to wait for a longer period of time. That kind of situation is known as a starvation. If the same transaction is rolled back for a several times and it has to wait for a longer period of time to complete its task, then such kind of situation is known as a starvation. Okay. So a transaction may be waiting for a X lock on an item while the sequence of other transaction and requests are granted on S lock on the same data item. In that case, that one transaction which requests X lock have to wait for a longer period of time. Or if there is any one transaction which has been rolled back frequently, repeatedly, then in that case also that particular transaction will be in a starvation. So how to prevent all these things? Now, concurrency control manager can be designed in such a way that it has to prevent the starvation. Okay. So now only we are going to see about two-phase locking protocol. So two-phase locking protocol, it is the most important topic. Before going to that, you should know what are the locks are there, how the locks works. So till now what we have seen. So till now we have seen that lock is a mechanism that is used for a concurrency control access on a data item. There is some common data items are there, and there should be, if that is to be accessed by many transactions, then that transaction first get the lock on the particular data item, then only it can able to use that. Okay. So there are two types of lock is there, exclusive lock and shared lock. Lock X, lock S. When you will be using lock X, when you want to perform the write operation, then you will be using the lock X. Lock X is used whenever you are performing the write operation. Lock S is used whenever you are performing the read operations. Okay. Janvi Priya, what time you are logging? So two type of locks are there on any data item, X lock and S lock. Lock X that is used for write operation, lock S that is used for a read operation. Okay. So we have seen about lock compatibility matrix. That is a shared lock can be granted for any number of persons. Shared lock can be granted for any number of persons at the same time. For example, 10 students are there. All the 10 students wants to perform read operation on a particular data item, that is possible simultaneously. But one person wants to perform read operation, another person wants to perform write operation. Now, it is not possible. Concurrently, you cannot perform read and write operation simultaneously. And if both the transaction wants to perform write operation, that is also not possible. Okay, so only possibility is all the 10% wants to perform read operation on a one data item simultaneously. It is possible. In all other combination, it is not possible. So that only shown in the compatibility matrix. Here we have taken two transactions. This is for one transaction and that is for another transaction. And one example schedule we have seen. So in the previous cases, we have seen the schedule with only read and write operations. But here, if you are going to use a log-based protocol, first you have to use a statement which is necessary to get the lock on a particular data item. Once you get the lock on a particular data item, then only you can able to access that particular data item. So that statement is added here. Lock S on A. S means it is a read. That means you are going to perform read operation. So first you are getting S lock on the data item A, you are performing read operation, then you are unlocking it. And then you want to read the B data item. For that also you want to get the lock. So lock S on B. And then you are performing read of a B, and then you are doing an unlock of a B, and then you are displaying A plus B value. Okay. So the problem which is encountered in a log-based protocol is a deadlock. So what is a locking protocol? Locking protocol is a set of rules that should be followed by all the transaction while it is requesting and releasing the locks. So the pitfalls of a log-based protocol. Pitfalls means you can say limitations or the disadvantage as deadlock. So here you see T3 is a holding one lock and T4 is a holding another lock. T3 is a holding lock on the data item B. T4 is a holding the lock on the data item A. And again it is trying for to access some lock on another data item. Here you see T3 is trying to get the A lock, but it is available with the T4. Similarly, T4 is requesting for S lock on the B data item, but that lock is already holded by T3. So in that state, the system will be in a deadlock. Okay. So the solution for it is either T3 or T4 have to roll back. So if we are doing that kind of rollback, if the same transaction is rolled back for a several times, then that will be in a starvation state. It has to wait for an infinite number of times in order to complete its task. Okay. So starvation can be handled by the concurrency control manager. Starvation can be handled by the concurrency control manager. Ritu, for your class time is 140. Yeah. So now we are going to see about two-phase locking protocol. So in the case of two-phase locking protocol, by the name itself, it shows that two phases are there. Phase 1, phase 2. The name of phase 1 is growing phase. The name of phase 2 is shrinking phase. So in the case of a growing phase, what you will do now, transaction may obtain the locks, transaction may not release the locks. Transaction in the phase 1, the transaction can obtain the lock on any number of data item, but it cannot release the locks. For example, you want to access two data item. Now you will get the lock for the two data item first. Then only you will start executing your transaction. Okay. So the two locks will be holded by you. Okay. So second phase is shrinking phase. So once you have used the data item, then in the second phase, you can release the lock. You can release the lock in the shrinking phase, but you cannot obtain any lock during the phase 2. During the phase 2, you cannot obtain any new locks. Okay. So two-phase locking, there are two phases. Phase 1, it is a growing phase. Phase 2, it is a shrinking phase. In phase 1, you can obtain the lock, you cannot release the lock. In phase 2, you can release a lock, but you cannot obtain the lock. Okay. So this two-phase locking protocol ensures the serializability, conflict serializability. Okay. So if you are going to use a two-phase locking protocol, then also there is a chance of a deadlock. Then also there is a chance of a deadlock. For example, we can take two students. Okay, so Vaishnavi and Yuvarani. So for Vaishnavi, she needs three locks on a data item A, B, C. So she got all the three locks. Okay, and Yuvarani need the lock on a two data item A and B. A and B. But she cannot A, B, and you consider one more data item D. So she can get the data item on a D, lock on a data item D she can able to get, but on A, B she cannot. Yuvarani cannot get the lock on the data item A and B. Why means it is already holded by Vaishnavi. So in that case, there is a chance of a deadlock. Okay. So how can you avoid such kind of deadlock which occurs in the two-phase locking protocol? Now, we can go for more somewhat modified protocols. The first protocol is strict two-phase locking protocol. Second one is rigorous two-phase locking protocol. So strict two-phase locking protocol, here the transaction must hold all its exclusive lock till it commits. Till it commits. So until a particular transaction commits, it holds all the exclusive lock. That is in the case of a strict two-piece locking protocol. In the case of rigorous two-piece locking protocol, it holds all the locks till it perform the commit operation. Till it perform the commit operations. But it is not in the case of two-piece locking. Two-piece locking, what is happening? At the first stage, it is getting all the locks. In the second part of its execution, it can release the locks. Any locks it can release in the second part. So in the phase 1, it is acquiring the lock, it is obtaining the lock. In phase 2, it is releasing the lock. In phase 2, it is releasing the lock. It is in the case of two-piece locking. What is happening in the strict two-piece locking? In the case of strict two-piece locking, it holds all the exclusive locks till it commits. Till it commits. In the case of rigorous two-piece locking protocol, it holds all the locks, both exclusive lock and the shared lock will be holded till that particular transaction commits. Okay. Once it commits, that time only it releases the locks. Okay. So that is rigorous two-piece locking protocol. So this why we are going for strict two-piece locking and rigorous two-piece locking now, in order to ensure that your two-piece locking protocol is free from the deadlock. Okay. And you can perform a lock conversion in the case of two-piece locking protocol. In the phase 1, you can acquire S lock on a data item, you can acquire X lock on a data item, you can convert S lock to a X lock. That is upgradation of a lock you can able to do. S lock, shared lock can be upgraded to lock X. For example, A is a data item. On that data item, first you got S lock. After some point of time, if you want to upgrade that to X lock on the same data item A, it is possible. Okay, that is known as a lock conversion. You are changing the lock on a particular data item from S lock to a X lock. It is lock upgradation. And in the second phase, you can release a S lock, you can release a X lock, you can convert X lock to a S lock. Here you are doing a lock downgrade. You are downgrading the lock. Exclusive lock to shared lock. You are doing downgrading. Okay, of a lock. It is also possible in the case of a two-piece locking. So in the case of two-piece locking, lock conversion is possible. In phase 1, you can do the upgrading of a lock. In phase 2, you can do the downgrading of a lock. Is there any doubt? Is there any doubt?
No, ma'am.
No, ma'am.
Okay. So here is a procedure that is used for automatic acquisition of a lock. Some routines is there. So by using this routine, the transaction can able to get the lock on a data item. For example, if a transaction wants to perform read operation on the data item D, it has to execute this statement. So what it is showing, first it has to check if that particular transaction TA is having a lock on D. Already if it is having a lock on D, then it perform the read operation. Else begin. If necessary, wait until no other transaction has a X lock on D. If any other transaction is holding X lock on D, then it has to wait. If it is not, in that case, the transaction TI gets a lock S on the data item D. Then it performs the read operation and end of the procedure. So again I am saying there is a one data item D, and that should be that data item wants to be read by the transaction TI. If that is the case, this routine to be executed. Then what TA transaction is doing? It is checking whether TA is already holding a lock on D, lock on the data item D. If it is so, then it perform the read operation. Okay. Else, it has to check, is there any other transaction holding X log on the data item D? If it is the case, then it has to wait. TI must wait. If any other transaction holding X log on the data item D. If it is not, in that case, TI will get the log S log on the data item D. Then TI will perform the read operation on the data item D. It is for read operation and write operation. If a TA transaction wants to perform write operation on the data item D, then same procedure. If TA has a log X on D, log X on D, log X is needed to perform the write operation. If TA is already holding log X on D, then it can perform the write operation. Else, it has to check. Else, it has to check. Is there any other transaction which is a holding log on that particular data item? If it is so, it has to wait. It has to wait. If any other transaction is a holding lock on the data item D, then it has to wait. If it is not, in, it has to check whether TA is a holding log S on the data item D. If it is so, then it has to upgrade that. It has to upgrade that. Upgrade log on D to log X. Already it is holding S log, that should be changed to a X log. Else, grant the X log on the data item D and then perform the write operation on the data item D. Okay. So once it completes a write operation, then all the logs should be released after the commit or the abort operation of a transaction. So if you want to perform, if a transaction wants to perform write operation, first it has to check whether it is already holding X log on that particular data item. If it is so, then it will perform the write operation. Otherwise, it has to check, is there any other transaction holding log on the data item D? If it is so, it has to wait. It has to wait. It will be in a waiting state. If any other transaction holding log on the data item D. If it is not, then it has to check that whether TA is holding S log on data item D. If it is so, then it has to upgrade the log. Upgrade the log now, S log should be upgraded to X log. Else, it has to get the log X on the data item D, then it has to perform the write operation on the data item D. Is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So who is doing all these works? For example, many transactions are running concurrently and all the transactions are sending requests and that log should be granted. That who is handling all those things now? There is a one person who is known as a log manager. Okay. So log manager is responsible for granting the log. All the transaction, if it wants to get the log, then it has to send the request for lock and unlock to the log manager. Log manager transaction has to send the request to get the log to perform unlock. So that request will be sent to the log manager. The log manager will give the reply to the log request by sending the log grant messages. Okay, so log manager is there. If there is a transaction which wants to get the log on a particular data item, the transaction must send the request to the log manager. The log manager will check, is there any other transaction holding lock on that particular data item or not? That and all will be checked by the lock manager. If the lock is available, that lock will be granted to that particular transaction. That will be given as a reply from the lock manager to the transaction. Okay. So for that sake, the lock manager is maintaining one data structure that is known as a log table. Log manager is maintaining a data structure that is known as a log table. So in the log table, he will be maintaining the information about what are the data items are there, who is holding that particular data item, what kind of log that is holded by that particular transaction, and who are all other person who is in a waiting state for that particular transaction. Everything will be recorded in the log table. Okay, so usually log table will be implemented as a hash table, and that will be indexed with the help of with the name of a data items. Okay, so this is the structure of a log table. You see here, so hash table structure is here. Here I'm having a pointer I7, I23. These are the data items. I7, I23, I912, I4, I44. All these things are the data items. Okay. So what is T23, T1, T8, T3 now? All these things are the transactions. T1, T8, T2, all these things are the transaction. I23, I7, all these things are the data item. That black rectangle is there now. Black rectangle indicate that granted locks. What type of lock? That also will be maintained here, but that is not shown here. Whether it is a S lock or X lock, that is not mentioned here in this diagram, but that also will be holded by the lock manager. What kind of lock is given to that particular transaction? So that black rectangle or black square specifies that lock is granted to this particular transaction. So I23 data item lock is given to T1 and T8, and T2 is waiting for the lock on this particular data item. Okay. So similarly, here you see I4 is a data item which is holded by T1 and which is waiting. T23 is waiting for that lock. Okay. So for example, here in this I4 is a data item, T1 is a holding, T23 is waiting. Once T1 releases its lock, then the lock will be allocated to T23. If a T1 is a holding the lock, that lock will be allocated, if a T1 is releasing the lock, then the lock will be allocated to T23. Okay, as at any point of time, the lock manager will have all the information. How many data items are there? Who's holding the lock on that particular data item, and who are all in a waiting state for that particular data item. All the informations will be maintained by the lock manager. So the lock manager will always keep the list of locks which is holded by each transaction. And what are all the transaction which is requesting, what are the data items, that list also it will be holding. So this is the log table structure. The black square specifies lock granted. The empty square specifies it is waiting for the lock. That I23, I7, this is the data item. T23, T1, T8, T2 and all transactions. Is there any doubt in this? Is there any doubt in the transaction manager and any doubt?
No, ma'am.
Okay. So implementation of lock is performed by the lock manager. Lock manager will be responsible for granting the lock, and it is responsible once the transaction releases the lock, it will be noticed, or it will be that the information will be maintained by the lock manager only. The transaction have to send the request to the lock manager for requesting a lock. If the lock is available, then the lock manager will send the reply as a grant lock to the transaction. If the lock is not available, then the transaction has to wait. So how the lock manager is maintaining all the informations now? Lock manager is using a one data structure which is known as a lock table. that lock table, in the lock table only, the lock manager maintains all the information. What all the data items are there, what are the transaction, for which transaction that lock is allocated, and which transaction is waiting for the lock on a particular data item. Everything is present in the lock table. So lock table is maintained as a hash table, and in the hash table it is using the index. What it is using as an index now? Data item. Data item is used as an index. So this is your log table structure. So hash table structure is given. So from the hash table, it is pointing to the data items. So, and this rectangle specifies a black rectangle specifies a rectangle. Here it looks like a square only. So black square represent that particular transaction is holding a lock on that particular data item. I7 data item lock is holded by T23. Okay, if there is an empty square is there. T2. T2 is waiting for the lock on the data item T20, I23. Okay, so that is shown. So at any point of time, the lock manager is maintaining the list of transaction that is holding what are the locks, what are the transaction which is holding what are the locks, and what are the transaction which is requesting for what are the data item. All the informations will be maintained by the lock manager. Okay, so what and all we have seen today? What and all we have seen today?
Log-based protocols.
Yes, we have seen about only one topic, that is log-based protocol. So log-based protocol is used whenever you are performing the concurrent transaction. Okay, and there are two type of locks are there, X lock and S lock. When you want to perform write operation, you have to get X lock. When you want to perform read operation, you have to get the S lock. And compatibility matrix, that is at the same time any number of transactions can perform the read operation on one data item, but all other possibilities are not allowed. For example, one person wants to perform read operation, another person wants to perform write operation, or both the person wants to perform write operation at the same time. It is not possible. Only read operation at the same time is possible. All other combination is not possible. That is shown in the log compatibility matrix. So before using any data item, first you have to get the log, transaction have to get the log, then only it can use that. It can perform read operation or write operation. And once it perform read or write operation, it has to release a log by using unlock statement. Lock S, unlock. Lock S on A, unlock A, like that. And then the problem with the log-based protocol is deadlock. The solution for deadlock is rollback. You have to roll back any one of the transaction so that you can come out of the deadlock. And whenever you are doing a rollback operation, then there is a chance of starvation. Starvation means if a same transaction is going to be rolled back for many times, then that particular transaction will be in a waiting state for a longer period of time. That kind of situation is known as a starvation. How can you prevent starvation? By using concurrency control manager. So two-phase locking protocol, two phases are there, growing phase, shrinking phase. In growing phase, you can obtain the locks, you cannot release a lock. In the shrinking phase, you can release a lock, you cannot obtain the lock. What's the next hour?
Max.
Okay. Sir?
Yes, ma'am. I'm here.
Okay, sir. Okay, sir. Thank you, sir. Thank you, students. We will see other topics in the next class.
Thank you, ma'am.